When you're done, you can scan the attendance. Okay? You ready? Yeah? Okay. Well, today's brakes, and I know it looks a lot, but a lot of it is redundant, so I just put all of them there. But I think a lot of these correlates a lot with our experience driving the car, so it should be easy. Let's begin with an overview here.
All modern passenger cars are equipped with disc brakes on the front axle, while the rear axle may feature either disc or drum brakes. Disc brakes offer several advantages over drum brakes, with the most significant being their superior heat dissipation.
Okay, well, it already gives you the the answer, but what is the job of the brake? Stop the car. But what is scientifically happening?
Well, friction.
Friction, and what does the friction do? Heat. Why is there heat?
It's rotational motion is being stopped, and the piston is gripping onto the disc.
Sure, but in a bigger picture, your car is a machine, right? The definition of a machine is an energy conversion and manipulation. So, your car burns gasoline, you convert chemical energy into mechanical kinetic energy. You're moving the mass, right? Half mv squared. And the friction converts kinetic into. So that is really the job, well, what is happening with the brakes. And a lot of people thought brakes are just, friction, right? But essentially, the design of brakes, friction is easy to achieve, right? But the question is, how do you do it in a controlled manner? One, vehicle dynamics and all that. Second, what's going to happen to the heat? So brake design is all about heat, actually, right? Look at those holes. Those are the vents, right? It's meant to be a convection pump, right? It's an air pump. It pumps air out as it spins. So let's look at the systems.
which results in more efficient braking performance. Let's take a closer look at the operation of the disc brake system. When the driver presses the brake pedal, hydraulic pressure builds up in the brake master cylinder.
Okay, so you have two pistons. If you look at that, they are in series. Anybody wanna, do you happen to know why? Why do we have two pistons? Why not just one piston pressing and creating the pressure? This is the first piston, right? Gives you this pressure. And this piston gives you this pressure. Brake systems are safety related, right? Now, I don't know if you notice, if you look closely, this piston does not press on this piston directly. It is actually separated. However, if something fails, and this happens to have leak, this piston will push on this piston and still produce pressure on the other one. So it's redundancy. Okay? So even if you have leak here, you will still be able to brake. So in the movies, when they cut one of the brake hose and the car suddenly have no way of stopping at all, that's not true. Okay? There are safety mechanisms to handle that.
The pressurized brake fluid is then transmitted through the brake lines to the wheel brakes, where it enters the brake calipers, housing the slave cylinders and pistons.
We'll talk about each
Pistons
component.
push the brake pads against the brake disc, creating resistance through friction between the pads and the disc. This friction slows down or stops the vehicle. Now let's delve into the design of wheel brakes and their key components.
So, hydraulics. You remember this from your, I don't know, junior high, high school, Pascal's law. What is Pascal's law says? Hydraulics. Pascal is the essence of hydraulics. No memory at all?
The force applied here is double or the area.
Okay, but why? Pressure. Okay. Area 1, area 2. What does the formula say? This is oil. So if the area doubles, the force doubles, right? So what would the formula look like?
F1 over A1
Mm-hmm.
equals to 2 into something.
Okay. And what is this? What is force divided by area?
Pressure.
Pressure, right? So it comes from the hydraulic law that all pressure here is the same, assuming that it's very little movement. We're talking about static fluid here. We're not talking about flow of water through a hose. So in hydrostatic condition, or almost static, the pressure all remains the same. And so if the pressure here is the same as the pressure here, then the force divided by area here that creates the pressure will be the same as pressure 2, and therefore if you rearrange, then, right, F2 is equal to A2 divided by A1 times F1. So the ratio of the area becomes the multiplication you get. Now, remember, there is no free lunch. Okay, there is no free lunch in science. So if I can multiply my force, I'll just, have a tiny area here and a huge area here, why not just do that in everything and hey, there is free energy? What is not free here?
Liquid usually is not like fully compressible, so it like lose energy.
It is incompressible, yes, but where will I lose my energy in the fluid? Yeah, maybe some heat, but we're talking about very little motion here. No? Okay. So if I press this 1 centimeter, what's your guess on here? If it's area 2 is twice area 1. The force is multiplied by 2. Conservation of energy. If I press with F1 and I get 1 centimeter, and F2 is twice of F1, what do you think is the displacement here?
0.5.
Huh?
0.5.
0.5. And how do you explain the conservation of energy? Let's say F1 is 100 Newton and F2 then is 200 Newton. What is the same?
Force over displacement.
Force?
Over displacement.
Force times displacement. What is that? What quantity is that? Force times displacement. Come on, it's physics. Force times displacement is? Begins with W? Work. Okay? So the work here, F times D, is the same as the work here. Because work is the change in energy, right? Conservation of energy. So if a cup of water goes from 0 degree or 25 degree to 100 degree, I boil it, then I'm putting work into the system, right? And then the energy goes from MC delta T, right? The water at 25 degrees Celsius and then becomes the water at 100 degrees Celsius. I'm putting work into the system. So here, I'm putting work into the system and I'm getting out the same. It has to be the same, right? So work in, work that I get. No extra, no free lunch, okay? So think about this in your hydraulic jack. You're racing your car. I mean, you never went to the gym, suddenly able to lift a car. How come? Well, you have to do it multiple times, right? The hydraulic jack, you have to pump it 10 times in order to get this much. See? So yes, you multiply your force 10 times or even 100 times, you get 1/100th of the displacement. And so you have to do 100 Newton multiple times. And that's the price you pay. Okay? So you can pay $100 or you can pay $1 100 times. Same amount of money, no cheating. So here, again, this is why your pedal will travel much, but here, it's only this much. Right? The pad only moves like 1 millimeter. But your foot goes in pretty deep, right? On top of that, there is a brake booster to help you.
Wheel brakes are made of cast iron or aluminum and can be categorized into two main types, those with a fixed caliper and those with a floating caliper. We'll start by examining the fixed caliper design. This system consists of a brake disc, brake pads, and a caliper that houses at least 2 slave cylinders with pistons.
In hydraulics, you often call this the master, this is the one that you press, so master cylinder, and this is called slave cylinder because it's the one that is being moved. In the case where you want to multiply the force, which is often the case, the master cylinder will have a smaller piston and the slave cylinder will have a bigger piston. Okay, as you can see, your brakes is usually about this big of a piston, and your master cylinder is only like a finger size diameter.
However, multi-piston configuration are also available, such as those with 4, 6, or even 8 pistons, evenly distributed on each side. These multi-piston setups enhance braking efficiency. The brake disc is attached to the wheel hub and is frequently fastened with one or more auxiliary screws to simplify maintenance and ensure proper alignment on the hub.
But these two, those two screws look small, isn't it? But they're not the one holding the brake rotor, by the way. What is holding the brake rotor?
The wheel.
The wheel itself.
Next, the brake disc is securely clamped by the wheel after installation and rotates along with it. The caliper is rigidly attached to the steering knuckle. The slave cylinders are connected to a flexible hose that delivers brake fluid. The brake pads are installed in place and held by pins. To reduce squeaks and rattling, various types of retainers and springs may be used. When the driver presses the brake pedal, pressure builds up in the slave cylinders, causing the pistons to extend and press the brake pads against the surface of the brake disc.
Movement is very
The
small.
harder the pedal is pressed, the greater the pressure exerted on the disc. As a result, the vehicle slows down or comes to a complete stop. As the driver releases the brake pedal, the pistons retract slightly due to the square profile sealing elements, which provide the necessary force for this movement. A special hood protects the piston from moisture, dust, and dirt.
Those are the maintenance items. You rarely have to replace the piston seals if this is maintained. When you see some tear, every time you replace the pads, you want to look at this boot. If you see some tear, then dirt and water can come in and will get there. So you want to change that before you have to, overhaul everything.
Additionally, the brake caliper is equipped with a bleeder screw for system maintenance.
Anybody knows what it is? The bleeder screw? You would know. It's
Remove air.
to remove the air and flush the brake system. Sometimes there is no air, but there is water mixed in with the brake oil, the hydraulic oil. So it is something that people underestimate, that the hydraulic oil needs to be flushed every, 50,000 kilometers or so. When do you usually recommend
Every
brake fluid?
second service.
Second oil change?
Second oil change.
Okay,
And then
that's pretty frequent.
yeah, that will be bleed the whole.
Oh, you just bleed, you don't flush.
No.
Okay, yeah. Yeah, I usually just bleed, like you said, every pad change maybe, or once a year, once every 2 years sometimes. The bleeder screw is kind of a unique screw. If you open it a bit, then it allows a tiny bit of opening, but you have to do it while the brake is pressed, because otherwise air comes in, not out, right? So during the flush, that's also the port where you flush the oil out.
Another important component is the shield, which helps minimize the entry of dirt and water into the wheel brake assembly. Now, let's turn to the most widely used type of disc brakes.
This is most common,
Working
obviously.
caliper design. This system also incorporates a brake differs from the fixed caliper design in that it features a fixed bracket paired with a floating caliper. The bracket is attached to the steering knuckle, while the brake pads are aligned with the help of special notches. When the brake pads press against the brake disc, they slow down the wheel's rotation. This function is performed by a floating caliper, which is mounted on a fixed bracket and moves along one axis with the help of two guide pins.
Okay, these guide pins is critical because if you think about it, let me finish the animation first.
The floating caliper houses a slave cylinder with a piston, typically one, though two piston versions are also common. The slave cylinders are connected to a flexible hose that delivers brake fluid.
The piston is the same.
When the brake pedal is pressed, fluid pressure causes the piston to extend and push against the
Okay, look at the mechanism.
Since the caliper is not fixed, it slides along the guide pins until the outer part of the caliper housing presses against the other pad.
Okay, so it's like if I'm pushing, if this is what I'm pushing one way, right? But my back is connected to the other way, and so action and reaction, if I push with 100 Newton, then my back also goes back, right? I'm not standing on, let's say I'm standing on ice, or I'm flying. So if I'm flying, if I push, then my back also goes back. And so if I connect my back with a bracket that goes to the other side, then I'm actually pinching this chair, right? Okay, so that's what it is. The piston push, but the housing of the piston goes around and goes to the other side and presses on this, and so you get action and reaction forces there.
As a result, both pads press against the disc with an equal force, braking the vehicle.
Now, let me ask you this. When will it not press with equal force? What is one flaw of this design? I mean, theoretically it should work, but what can happen? Yes.
Gliding pin usually is the main reason why it isn't.
What happens if something happens to the gliding pin?
It creates resistance when when gripping. So usually what happens, the inner one wears more, or it
When the
wears
brake pedal is pressed,
diagonally.
fluid pressure causes the piston to extend and push against the inner brake pad.
Okay? Look at the guiding pin. What is it supposed to do? It's supposed to slide, right? Well, what if it's not? What if it's dirty and it's not maintained very well?
Sometimes with heat it sees out.
See that? So this guide pin is also a maintenance item. It's a crucial one, by the way. So you always dismantle it, spray brake cleaner all over, grease it again, and so it has to float. So if you hold on to the head of this brake caliper, with some gap, if you move it, it's supposed to move. It's not supposed to be fixed. It's supposed to float. Okay? So this is a big maintenance item that people often underestimate. So can you guys see that if the guide pin does not slide, what happens? The piston will push on this pad, but the entire thing is not moving. And so what happens to this pad? It's not pressing against the disc, right? So what do you think is the plus and minuses of fixed and floating? Fixed caliper, like double-sided piston,
It's
versus floating.
Usually the fixed one they use it in like the more sport oriented car.
So this is the fixed one. You know, if your maintenance is done correctly, I don't think there's any difference, right? And we'll talk later, because really, in many brake situations, adding one more piston is not helping your brake. Because the problem is not how many pistons. The problem is the entire braking dynamics. And we'll get to that. I don't want to spoil the story, okay? But fixed caliper versus floating, the only thing I can think of is cost. This is almost double the cost. The pistons and all the arrangement, the complicated housing, you have the hydraulic channel going through. It's money. And that's why you will see floating piston in like many cars, except like the eccentric. You know, at one point, what you pay for a Ferrari is not just the car, right? It's the image, it's the aesthetics. Okay, so that's a good overview. This other video actually says about the same thing, but I don't know if there's anything we haven't talked about. We talked about that, Pascal's law, yeah. We'll have, well, this is a good naming of the, let's watch this a bit. So wheel hub bearing, right? There's a bearing inside that. And then the rotor comes in over that. This is called the brake rotor in English, or brake disc, but oftentimes people say brake rotor, like the rotor in a motor. And that's the one taking the heat, by the way. Yeah, talked about that. Okay, this is a nice image, right? See the guide pin? So the two bolts that's holding the pin is not load bearing at all, actually, right? So when you want to remove the brake caliper, you take off the two caliper bolts, and the caliper bolts only hold the pin. So that's not load bearing. The one that is load bearing is the caliper bracket, and that's why you see a much bigger bolt there. It's just holding the slider pin. As long as the slider pin is there, your caliper is not going anywhere. Okay. So, what I like about this animation is this assembly. So you see this bolt. It's a special bolt. It's called a banjo bolt because there is a hole for the hydraulic fluid to come in. And this hopper washer is something you replace. It's made out of copper because it's soft. And it's supposed to basically, I mean, think about the head of the bolt. This surface has to be sealing, right? And then there is the banjo connector. This is where the fluid comes in, okay? There is a hole, and so fluid comes in here and here, okay? Now, you have, and this is the caliper, you see? So you have to have sealing, right? Otherwise, I mean, it's gonna seep out here. So you have to have sealing, good sealing here. You can just rely on a very smooth bolt, but no matter how smooth of a surface, you will have imperfections, right? And so if you zoom out on the head of this bolt, it's not like this, it's like that, right? And with a lot of pressure you're dealing with, you're gonna have some leakage. And so what does the copper washer do? Well, because it's a soft one, it's a soft metal, when you compresses it, it basically conforms to the imperfection on both sides. So that's what the copper washer is. You know, so this copper washer, this surface is going to be damaged. It's supposed to be. When you tighten it, it basically conforms to the imperfection and it creates a good seal. And that's why it's something you're supposed to replace every time you take off that bolt. Okay, piston, pins, okay, we saw that. Fluid comes in, yeah. Okay. So I want to just show that disassembly or exploded view from this one. This one talk more about the master cylinder. So let's talk further on the master cylinder and the brake booster in this video.
Brake system works. In the last part, we saw the working principle of the wheel side. The master cylinder is the main part here. It transfers the force on the pedal to the calipers. There is a push rod, outlet port, and a fluid reservoir tank. Let's see what's inside the master cylinder. There are inlet ports for the fluid to reach the cylinder, compensating ports, primary piston, secondary piston, retaining springs, and piston seals. Now, let's see how the master cylinder works. When you press the brake, the push rod pushes the primary piston, closing the first compensating port. This creates pressure in the cylinder, which pushes the secondary piston, and furtherly closing the second compensating port. Hence both pistons will push the fluid to their corresponding calipers.
Okay, now these two ports are connected sometimes to the front and back. So one goes to the front, one goes to the back. Oftentimes they are actually in a diagonal situation. So one port actually goes to the left front and right rear. The other port goes to the front right and left rear. So if one fails, you got kind of a more symmetric braking.
In case if the secondary piston fails to build up pressure, the primary piston can still develop pressure with increased travel.
Okay, so if the secondary piston, let's say this one leaks on the brake lines or the brake hose, right? If somebody forgot to assemble it or some crime, criminal cut the hose, then there is no pressure here. Therefore, it fails to build up pressure. Now, the other port will still build up pressure because, first of all, it's separate, and that will hit the end of the master cylinder, and so you can still build up pressure on this chamber.
And if the primary piston fails, the secondary piston will not receive any pressure to move. So the push rod at the end of the
okay, so it's going to hit the rod, and it's still going to mechanically push it.
First piston can push secondary piston, which requires much force to be applied on the brake pedal. Even for a fully functional master cylinder, pushing the pistons through the brake pedal requires much force. So later on, another component named boosters were introduced. The brake booster comes between the pedal and the master cylinder and utilizes the vacuum from the engine, assisting the brake pedal and makes it easier to apply brakes. Let's take a look inside the servo. It consists of a valve rod, dust boot, air filter, valve spring, diaphragm spring, vacuum check valve, hydraulic push rod.
Okay. So this brake booster is something to help you push, because even with the hydraulic systems, I mean, think about it, you're only getting what, 5 times multiplication? So this thing is still very hard. Where does does the power to help you comes from? It comes from vacuum. And the vacuum is connected to the intake of the engine. Now the intake port or the intake manifold is actually not vacuumed all the time. Think about it. It's taking air from the surrounding air, so it's not vacuum. This is the engine, piston, connecting rod, crankshaft, intake, and exhaust. Okay, so this is called the intake manifold. It's where the air comes in. Okay, there is a valve on there. Now, if this is the intake manifold, there is something here called the throttle to actually manage the amount of air coming to your engine. And so this throttle is basically a butterfly valve rotating like this, right? When it opens, it's full open throttle, right? When it closes like this. However, there is still a little bit of idle air seeping through, either through the opening of the butterfly or through the idle control valve, okay? Older cars have this idle control valve. Throttle by wire systems, they just simply open it a bit and it's by program. Either way, there is still this tiny opening. Now, your engine is a pretty powerful pump. Okay? It's a pretty powerful pump. It actually sucks in a lot of air and gives out a lot of air with some pressure too. And in the process of doing so, it's making power here. Okay? That's what your engine is. It's a pump. Now, think about a very powerful pump sucking air here. If it's wide open, then there is not much vacuum actually, because we want this to be opening to the outside air as much as possible, right? Taking in air. However, think about an idle situation, or when your throttle is all the way out, and you're actually think about a very powerful pump sucking in a tiny straw, and the straw is really tiny. Ever tried to sip your coffee through the stir? It's not meant to be a straw, it's a stir, right? But there is a tiny hole going through. So if you try that, it's a lot of vacuum. And so that's what our engine is doing during the time when you release the throttle. Your engine becomes a vacuum pump, essentially. And so this is surrounding air outside, right? This is your air filter, and you know, it's wide open, right? But here it's choked. It's choked, and so here there is vacuum. Quite a strong vacuum, I should say. If you ever try to hold on that hose while the engine is running, I mean, you can be injured. If you try to hold, put your hand over the throttle while the engine is starting, it's a pretty powerful vacuum. Okay. So again, this is where the vacuum we're going to tap to help us with the brake booster.
When you push the pedal, the valve rod opens the inlet valve, allowing air into the diaphragm front chamber through the filter. This air, along with the vacuum created by the engine in the diaphragm rear chamber, pulls the diaphragm, and furtherly pushing the push rod towards the master cylinder. Thus provides assistance, and reduce the effort in braking. And that's how an automotive braking system works. Thanks for watching, and stay tuned for more presentations from braking.
So, brake booster, basically the vacuum is on this side, and outside is just atmospheric. I mean, we're not applying pressure from this side that way. We are sucking air here, and this diaphragm, why does it have to be big? Why do we have a big brake booster.
Same principle as the hydraulics.
Because pressure is force over area, and so force is pressure times area. The bigger the area, the bigger the force. So with the same vacuum, I can pull in a big force there. This thing pulls in with a big force. And so when you're pressing on the brake pedal, you are releasing on the throttle, obviously, right? And this is why your brake booster is not live, it's not on if your engine dies. Ever try a stunt? You turn off your engine and then try to brake in the highway. Okay. It's heavy. It's heavy. And if you ever try to push a car also and press the brake, I mean, you'll feel that, why is my brake like only 1/10 of the force it used to be? Well, because the engine is off. If the engine is off, there is no vacuum, and your brake booster is not helping you. It's still working because it's mechanically connected, right? It's mechanically connected. But this thing is not helping you at all. So that's what happens. Your brake is actually very heavy, but the brake booster helps you. Okay? I think that is a good discussion on master cylinder and brake booster already. This is a good video on the disassembly of it.
Today I'm going to show you what's inside of a brake master cylinder and booster and how it works to stop your car. Now the brake booster is responsible for multiplying.
Okay, I'm just going to mute that because we know. But I want to show you how it looks like in the real world, I guess. That's the master cylinder, that's the booster. Did I pause it? So that's the vacuum line, right? That's the vacuum line. This is the master cylinder. And this is the reservoir. Okay, that's the brake pedal pressing in. Okay. It's held by it pushed directly behind the brake booster. That's just a bracket. There's a brake switch there. That's a brake line. Notice, by the way, the brake line is actually a rigid pipe. This is a rigid pipe. It only becomes a flexible hose near your caliper, then the pipe becomes a hose. Make a guess. Why do we have pipes instead of hose?
Because of the pressure.
The pressure. And what if we have a hose all the way from here all the way to the brake caliper?
So when it breaks, it's gonna flex.
It flexes and it actually expands.
Yeah.
It actually expands, and what will you feel? What's the impact on your braking?
Soft.
It's very soft, very soft. And so we have pipes all the way to the caliper, and then only when near the caliper you need a hose, because obviously your wheel goes up and down. So he always used clothes from his brother. Okay, so that's the pieces, that's a master cylinder, it's just a strainer, that's a sensor, gives you a warning light if your brake fluid is out. That's a sensor for the brake fluid, like a fluid. Alright, so this is a piston, the springs. Okay, I just want to show you how it looks like in real world. So they're all connected. That is just a filter for, so debris does not comes in. Okay, so that's a big plate, but there is a rubber on the edge. Okay. So when you press, you're actually being helped with this diaphragm. Just a spring return. So that's the kind of the regulator, so-called, to allow how much boost you get, right? Because it has to be linear. You don't want your engine to be braking for you. You still want to control it with your legs. That's just a sensor. That's a brake switch for your brake light in the back. Okay. Any questions so far? Okay. Well, we haven't talked about drum brake. The mechanics is different, but the hydraulics all are the same. Okay, so you got the drum, you got the assembly. You got two brake shoe, right, left and right, and they're being pushed. This is a drum, so this is the friction point is actually the inside of this. So on old cars, you'll see this taken up a little bit, right? It's worn out. So the drum actually rotates. The shoe is stationary. The drum rotates with your wheel. And so people call this the brake shoe instead of the brake pad, and it goes out. I don't like changing this brake shoe. It's a lot of spring. I hate it. The piston is on the top. A lot of moving parts here, by the way, so that's why it can get noisy if it's dirty. It's just a plate assembly. So the piston is here. This is the pivot. This is just a pivot. What do you talk about? Why is it so slow?
The wheel cylinder is connected to the hydraulic system and contains pistons which are forced outwards by hydraulic pressure when the brake pedal is pressed.
Okay. So it kind of rotates like that.
Shoe retaining springs pull the brake shoe down onto the back plate, keeping it in position.
You know, I often thought, why, like, if you have this kind of arrangement, you won't have full contact because it's pivoting like that. I don't know. This thing is probably adequate. This probably flex a bit. You know what I'm saying? It's like I felt that because it rotates here, I don't think it makes full contact. I don't know, maybe it does.
No, only the outer one goes. No, actually the shoe is thicker on the bottom, so you have right and left.
They compensate on that
They
thickness.
have right and left, so you want to put right, left. Even so, rear has right and left, and the rear right has right and left.
Yeah.
You can't be switching any of it, or it's going to be uneven wear. Because
Right.
the lower part is thicker than the no, the upper part is thicker. No,
No,
the
you're
lower part
correct. The lower part is thicker.
than the upper
So
part.
it compensates, so when it swings, you make full contact.
Yeah.
Good point. Never noticed that.
A tensioning spring is fitted to the shoes. When the brake pedal is released, hydraulic pressure is reduced, allowing the tensioning spring to withdraw
So the
wheel
spring is
cylinder
just to pull it
pistons
in.
and pull the brake shoes away from the drum. This allows the wheel to rotate freely once more.
So you want to put grease here or some lubrication.
Drum brakes use a self-adjusting mechanism. The adjuster takes up excessive clearance created as the friction material on the brake shoe wears, reducing the return movement of the shoe.
It's a ratcheting
This
mechanism.
effectively brings the brake shoes closer to the drum and maintains a consistent pedal feel and braking response.
It's to compensate for the fact that friction material comes worn out and you have bigger gap. You don't want that. With the brake disc, you don't have that situation because the piston just keep adjusting in, right? Here it's not because it's being pulled in by the spring, not by the natural bouncing of the seal in the brake disc situation.
Finally, we have the handbrake mechanism.
Because it's often for the rear, so you have handbrake here.
The handbrake cable enters the drum through the back plate and connects to the brake shoe lever arm.
Safety philosophy always adopts a failure approach, right? For anything safety related. So the handbrake is mechanical intentionally because your primary brake is hydraulic and your emergency brake, I mean we call it parking brake, but it is really emergency brake. It's supposed to be something that works regardless if your primary system fails. So if you have hydraulic, then your handbrake or your emergency brake is mechanical. Or these days what we have is electrical parking brake, but nevertheless it's separate. Okay, so it cannot be the same system. You have to have redundancy. By definition, that's emergency.
Cable, electronic and hydraulic systems are found in handbrakes, but in our example, cables are used to activate the rear brakes.
Okay, that's enough for drum brakes. So for rear disc brakes, it is still a mechanical emergency brake mechanism. So you have like a screw motion that when you pull on the emergency brake, it kind of have this motion mechanically linked. And so the rear disc caliper is usually a bit more complex because of this parking brake situation, and that's why to push the piston back you have to have a tool. It's very annoying because it's often corrode. Annoying. I hate working on the rear. Okay? Any questions? No? Brakes are pretty simple, but it's also an amazing design.
The CX30. We're choosing a mild.
Let's talk about brake bias. Okay? Because braking is also not as simple as four wheels clamping down. Because there is dynamics. What I mean by dynamics is that a car also shifts its weight to the front. So think about it. What if you do not manage the front braking force versus the rear braking force? What will happen?
Slide. On the steer.
Which one will lock first? No?
Rear one.
The rear one will lock first because the weight shifts to the front, and so you got a good grip on the front, and in the back it's lifted. And this is also a good time to discuss about big brake upgrades. I think this is an interesting discussion. People often upgrade their brakes from a single caliper to like a double piston or even a fixed caliper, a big brake with 6 calipers, both sides. Big brake kits. Do you think it works or it doesn't? Is it a worthy upgrade?
Yeah, it depends what you're doing.
Okay.
So, if you're doing a competition requiring high braking and lots of cornering, so upgrading your brake is a must because.
Okay, I can see where you're going, but before we go there, let me ask you this. Will a big brake kit, will a brake upgrade stop your car sooner? So you go from 100 km per hour to 0. Does it reduce your braking distance? Will a bigger brake or a bigger disc, sometimes people, bigger rotor, more piston, will it increase the braking force? Of course, that's just Pascal's law. but will it reduce the braking distance? What do you think, Mika?
Not really,
Why?
because it depends on the braking bias for entry.
Okay, braking bias, but then after the brake, then what do we deal with? How does the brake stop the car? Other than the wheel? Huh? Friction. Not just brake friction, but tire friction. So think about braking on ice.